Hello and welcome to the last section of our course. As usual, let's start with a math puzzle, and today we can see the site, can recognize the city. This is New York City, right? And the very famous building, the Empire State Building. If you drop a coin from the roof of the Empire State Building, 1,296 feet high, how long it will take for the coin to hit the ground? And this is free fall. You're not tossing, you're not throwing, and you need this formula here. This is the formula of an object in free fall. The distance in feet is equals to 16 times time squared, time in seconds. Think about this puzzle, this math question, and at the end of the section we bring you the answer. And today we are working on chapter 8, quadratic equations and functions, and we will work on section 8.6, last section of our course, for the graphing of quadratic functions. The first objective is to write quadratic functions of the form y equals a plus x minus h plus k. Let's understand what does it mean. This is actually, let me fix something here. This is actually times, right? This is times. No problem. Let's move graphs of quadratic functions. We know that the graph of a quadratic function is a parabola. This is the name. This is the kind of graph we will find for the quadratic function. If you write the quadratic function as a and then parentheses x minus h squared plus k, you can identify easily the vertex, which is, and you can see here, h and k, right? H and k, the coordinates of the vertex, x equals h, y equals k. Since we can find a lot about the quadratic function before we ever graph it, it will be in our best interest to get the quadratic into the appropriate form. So we can change, if it's in a different form, we can change the form so we can have the adequate information. The techniques we use will be similar to the completing the square method. Example, graph f of x equals negative 3x squared plus 6x plus 4. Find the vertex, axis, and any intercepts. Let's rewrite this equation and make it look like the form that you have seen before. Let me just write down again the form. F of x equals a times x minus h squared plus k. So we want this form, f of x equals a x minus h squared plus k, right? And now what we're gonna do, we will change a little bit we will change this shape, this form of the equation, and it's going to be like completing the square. Well, let's now bring this equation here, f of x equals, and we can start by factoring out negative 3, right? Factor out negative 3 and write x squared minus 2x, and we can just leave this positive 4 here on outside, because we will try to complete the square inside this parentheses. F of x, to complete the square we have to add b squared, and b equals 2 divided by 2, 1, and b squared is going to be x squared minus 2x plus, if b equals 1, b squared is also equals to 1. And we added 1. After we multiply by -3, we're going to have -3. So to balance the equation, let's add +3 here. So we balance, right? Since we add +1, will become -3 times +1, -3. So we have to balance by adding +3 here. Okay, we completed the square. Now we can write down this as this is a perfect square trinomial. We can write down as a perfect square, which is -3 times x minus b, and b is 1 squared, plus what? Plus 7. This is very useful, very nice, because we can compare with this form. We can find h equals 1. We can find k equals 7. So the vertex is x equals 1, y equals 7. This is the vertex, right? Complete here, 1 and 7. The axis of symmetry is the vertical line that cross the vertex, which is going to be x equals 1, right? If the vertex is x equals 1, y equals 7, the axis of symmetry is going to be x equals 1. Now let's try to find the intercepts. We can make, to find y-intercept, we make x equals 0, right? To find y-intercept. So f of 0 equals -3 times 0 minus 1 squared plus 7. And this is going to be equals -3 times -1 squared is 1, -3 times 1, -3 plus 7, 4, positive 4. So the y-intercept, this is y, right? Y-intercept equals x equals 0, y equals 4. Now let's find out x-intercept. To find x-intercept, we make y equals 0. Right? Let me select this column, y equals 0 to find x-intercept. That means 0 equals -3 x minus 1 squared plus 7. Right? So we can write down here, we can move this to the other side. Get this column. If we move this to the other side of the equation, we can write as +3 times x minus 1 squared equals to 7. Divide both sides of the equation by 3, and you have x minus 1 squared equals 7/3, right? Apply a square root property, and this is going to be positive or negative. So we can find the x-intercept. We're going to have two x-intercepts. First one is simplify, right? So first one is going to be, and this one moves to the other side, 1 minus square root of 7/3, and the second one, 1 plus square root of 7/3. Y equals 0. if you're going to represent using points, using coordinates, you're going to say the x-intercepts are x equals 1 plus square root of 7 over 3 and 0, and the other point x equals negative 1 minus square root of 7.7 over 3 and y equals 0. Okay, we have the vertex, we have the axis of symmetry, we have the y-intercept, and we have the x-intercepts. All this is going to be very useful to draw the graph. So let's start with the vertex. X equals 1 here, and y equals 7. 1, 2, 3, 4, 5, 6, 7. And we're going to have the vertex right here. This is the vertex. The axis is 1, so this is the axis of symmetry, x equals 1. The point, the y-intercept is x equals 0, y equals 4. 1, 2, 3, 4. Okay. And we also have the x-intercepts. If you try this on your calculator, this is going to be approximately 2.53, and the other coordinate and 0, and the other coordinates is 1 minus 7 square root of 7 over 3 is going to be negative 0.53 approximately, and 0. So let's draw the graph. 2.53, 1, 2, 53, somewhere here. And the other one, negative 0.53. Right? Look, we have several points. I think now we can work out and draw our graph. The parabola pointing, the opening of the parabola is pointing downwards. This parabola goes all the way down to negative infinity, and yeah, that's it. This is the shape that we are looking for. Next objective, derive a formula for finding the vertex of a parabola. You can do the way we have done on the last example, by changing and completing the square and making the form of the equation the same as the one that will help us to find the coordinates of the vertex, or we can use a formula. We can find the coordinates of the vertex if we have this form of the quadratic equation, ax squared plus bx plus c. We can find x of the vertex is going to be negative b over 2a, and the y of the vertex, you just plug in this x into the function, into the equation that you have. So it's f of negative b over 2a. Okay? Let's understand by working on an example. Find the vertex of the graph. F of x equals x squared minus 4x minus 12. So find first x of the vertex. Let's call it x of the vertex equals negative b over 2a, and b is negative 4. That means negative 4 is positive 4 over 2 times 1, and this is going to be 2. And y of the vertex is f of 2. So plug in x equals 2, 2 is squared, minus 4 times 2, minus 12, and this is equals to what? 4 minus 8 minus 12. So 4 minus 8 minus 12, negative 16. The vertex is 2 and negative 16. X equals 2, y equals negative 16. Okay, next objective, find the minimum or maximum value of a quadratic function. The quadratic function whose graph is a parabola that opens upwards has a minimum. That means if the graph looks like this, it has a minimum. And the quadratic function whose graph is a parabola that opens downwards, that means if the graph is something like that, it has a maximum. The f of x or y value of the vertex is the minimum or maximum value of the function, right? If you're being asked about the minimum value or the maximum value, you know, depending on the opening of the parabola, this is going to be the vertex, the y of the vertex. And let's work on an example. The Utah Ski Club sells calendars to raise money. The profit P in cents from selling X calendars is given by the equation P of X equals 360X minus X squared. What is the maximum profit? First, let's understand if we have a maximum or a minimum on this equation. This is the function. You have to find the value of the coefficient A. Coefficient A is the coefficient of the quadratic term, the square. And we can see here, A is -1. If A is negative, the parabola, the opening of the parabola is pointing downwards. We're going to have a maximum, right? That means, yes, we can find the maximum. You just need to find the x of the vertex equals negative b over 2a, and b is 360, negative 360 over 2 times -1, right? This is equals negative if negative positive, 360 divided by 2, 180. Now you plug in into the function, actually the function is P of X, and X is equals to 180. $360 times 180 minus 180 squared, right? If you do your calculations, you can find something like that. P of 180 equals 360 times 180 is 64,800, and 180 squared is 32,400. The right answer is 32,400 cents, right? And we can change this into dollars. Equals $324, right? Now we can solve our math puzzle. Have a look. If you drop the coin, you're dropping, you're not throwing, you're not tossing. You're dropping the coin, it's a free fall. We're going to use this formula of free fall. But you don't need to know the distance, you need to find the time. We just need to change this formula a little bit, divide both sides by 16, right? And then you're going to have t squared equals d over 16, and apply the square root property on both sides. You're gonna find t equals square root of d over 4, right? Now you can find the time. Time in seconds equals the square root of distance in feet over 4. Let me bring my calculator here to help me. Type in your calculator. Let me show you my calculator. Type the numbers. 1296. The square root is going to be 36. 36 divided by 4 equals 9. That means the time is going to be 9 seconds. Let me write down the time here. Time right here. Time is 9 seconds for the coin to hit the ground from the top, the roof of the building, until it hits the ground, the avenue at the bottom of the building. Thank you very much for joining this section, for following the whole course. This is the end, the last section, and good luck on the final exam.